In this question, we're given a continuous time signal that is sampled, and we're asked a few questions about the sampled signal. We're asked for the first value, the fifth value, and the difference between the first and the eventual value. So let's start with what we're given. We're given the sample period. So that's our TS. That's really valuable. We can use that to find the sample rate. The sample rate is just 1 over TS, but we don't need that. So the first step is to rewrite V of t as a discrete time signal. And to do that, we'll replace t with n times the sample period, Ts. So wherever we see t, and that's only up there, we replace it with n times t. So we have 100 plus 50 times 1 minus e to the minus. So instead of t, I'm going to say n times 4, and then divide by 20. So that's my signal. It then says find the first value. So the first value is when n equals 0. So we want V of 0. So we simply replace 0 up there. And you can probably tell that the first value is going to be 150. No, it'll be 100, because you have 1 minus 1, so the first value will be 100. Okay. It then asks for the fifth value. The fifth value is when n equals 4. So we want V of 4. So we simply replace m by 4, put that in your calculator, and that gives you 127.5 volts. And it also indirectly asks for the eventual value, or the final value. So the final value is when n is very big. So as n approaches infinity, this term here will approach 0. So you'll have 150. So you'll have 100. So V is 100 plus 50 equals 150. Now, I put that for illustration, but we're not allowed to say that because there is no such thing as V of infinity. So we'll just say the final value, or the eventual value, the final value. So it asks for the difference between the first, which is 100, and the final, which is 150. So we just say the difference equals the absolute value of 100 minus 150 equals 50 volts. And that would be your final answer.